Problem number 28 in section 6.4 asks us to find the probability that a couple planning to have 4 children have more girls than boys. I'm going to write that down in English. Probability of having more girls than boys. And now what I want to do is actually write this in terms of exactly how can this happen? How can we get more girls than boys? So we're looking for having more girls than boys. So 2 girls and 2 boys would be even, and we want more girls than boys. So we're looking for the probability of 3 girls or 4 girls. Now, let's get this in terms of everything that we're dealing with. We're dealing with girls and boys. So I want to write each one of these in terms of girls and boys. So I'm going to write this like this. I'm going to use a square bracket. If I want exactly 3 girls, this is going to happen if we get 3 girls and 1 boy. That'll give us the 4 kids. Or, now here I want the 4 girls. So that's going to happen if we get 4 girls and 0 boys. Close and close. Now, let's make these counts. What we want out of 4 kids, we want 4 of those kids to be girls, and then there's only 1 kid left, and that has to be a boy. Or, out of the 4 kids, we want all 4 to be girls, and then there's 0 left, and we want 0 of those. But now we also need our denominator. Now the denominator is what are the ways we can get 4 kids? So we could get 1, 2, 3, 4. We could get 2 choices here, boy or girl, 2 here, and 2 here, right? Boy, girl, boy, girl, boy, girl, boy, girl. So all in all, we're going to have 2 to the 4th, or 16. And when I computed this, I got 0.3125 when I write it as a 4-place decimal. In problem number 30, we're told that a bag, let's draw ourselves a bag. We have 9 tomatoes, of which 1 is rotten. So there's 1 rotten, and that must mean 8. I'm going to write it this way, not rotten. So n is equal to 9. There's 9 tomatoes in the bag, and we're going to take a sample of size 3. I'll call the sample R. So n equals 9 all together, and R, the number we're going to select is 3. And what we want to know here is what's the probability that the sample contains the rotten tomato? So what I'm going to think of is this. I want to get the probability of, now I want to put everything in here. I want to write this so that it includes everything in here. That way I can get my count. So I want the rotten tomato. So if I want, out of 3, we want 1 rotten. That means we want 2 not rotten. So let's make this count. Out of 1 rotten, we want it. Out of 8 non-rottens, we want 2 of those. It's a probability, so we're going to have a denominator, and the denominator is all the possible things that could happen. So out of 9 tomatoes, we're going to choose 3 of them. That's what we're looking for. And again, when I computed this one, I got 0.3333 to 4 decimal places. In problem 31, we're going to toss a coin 6 times. So we're going to toss it 6 times. What is the probability of obtaining exactly 3 heads? So what we want here is the probability of getting exactly 3 heads. Now, if we're going to toss it 6 times, we're going to need 3 heads and 3 tails. So I'm going to rewrite this one as 3 heads and 3 tails. That way I'm writing this in terms of everything that could happen, right? We could get heads, we could get tails, and I want everything down here so I can get that count. Now, how can I get the 3 heads? Well, what we're going to do is we're going to toss this coin 6 times, and I want any 3 of those tosses to be heads. Then, for the 3 tails, we've tossed it 6 times. We've already got our heads, right? We've tossed it 6 times. We've already selected 3 to be heads, so there's 3 left, and we want all 3 of those to be tails. And our denominator, now the denominator, what we're doing is we're tossing this 6 times. 1, 2, 3, 4, 5, 6. The first toss could result in a head or a tail, 2 choices there. the second and a head or a tail, 2 choices. So there's 2 choices for each of these. So this is 2 to the 6th, which is 64, and that's what we're looking for. And when I computed this, I got 0.3125. Problem number 32 tells us that a vacationer has brought along 4 novels and 4 nonfiction. So maybe we got a box, and in our box here we have 4 novels and 4 non-fiction books. So let's see, n is equal to 8. And then we're told that one day the person selects 2 books at random, right? So r is going to be equal to 2 here, to take to the beach. What is the probability both are novels? So what we're looking for is this. What is the probability? I'll write it in English first to give me a chance to think about what I'm doing. Both are novels. So let's rewrite this. How do we get both novels in terms of everything that's in here? So we can count this like this. There's 4 novels. We want any 2 of those. There are 4 non-fictions. We want none of those. And a probability, so we have a denominator. And what we're doing is out of our 8 books, right, we've got 8 books, 4 of each type, and we're going to choose any 2 of those. That's the probability that we're looking for. And when I computed this to 4 decimal places, I got 0.2143.